route of the proper circle we need to, we're asked to find, okay? To start with, you want to remember that Euler and everything that Euler says, start with EU, LER, start with an E, remember? So you want to go through every edge. You want to go, hold on, okay. On any map, you want to go through Euler's, an Euler circle and Euler path, go through every edge once. Now, if you have a path, you will set in one vertex and you will end in another vertex. But if you want to circle it, you will set in one vertex and you will end on the same vertex. All right? So for example, I have this graph right here, and I want to know if I want to do an Euler path for an Euler circle. You will have to go through every single one of these edges, every single one of them once. So you want to go from A to B, B to C, and so on and so forth, on each one of them once. But there is Fleury's algorithm, if I'm pronouncing it right, Fleury's algorithm that tells you what path to use. But before you do that, you want to know which one of these two you have. If you have a path or if you have a circuit. The way to find it out is by the number of odd vertices in the graph. So you want to count the odd vertices. That's what you want to know. That's the important part, the number of odd. If you have two odd vertices, I'm sorry about that. A circle that will be something with 0 odd. I'm sorry. Let me spell it out right. 0 odd vertices. If you happen to have more than two vertices, more than two odd vertices, you have neither. That you cannot make an Euler path on an Euler circuit on that graph. Let's count this graph right here that I have. A has two lines gone out of it, right? 1, 2. So this guy is even. B has 1, 2, 3, 4. That's even. D has 1, 2, 3, 4. And C also has 2. That's also even. We have no odd vertices here, right? So we can do an Euler circuit. This is just number 1. You can start any vertex you want, and you will end on any in the same vertex. So we can go from A to B, B to C, C to D. Then we can go from B to B, back to B, and back to A. B, 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 back to A. Now, if you don't want to get confused what route you already take, you can always number the edges, or you can just mark them as you are going through. I went from A to B, so I went that way, A to C, C to D, D to B, back to D, and down to A. That way you avoid yourself to retracing an edge to already traced. This is the other option. The other kind of graph that we have could be this one. Let's count the vertices. So A has 2, B has 2, C has 3, D has 1, 2, 3, F has 2, and E has 2. So C and D are odd vertices. We have 2 odd vertices. That means that we can have an Euler path. If you have an Euler path, you want to choose one of the 2 odd vertices to start with. I'm going to choose C because it's closer to me. From C, I can go to A. And from A, I can go to B. Back to C. When I cross out to the other side, I'm going to go to D. Go back to E. Go down to F. And then back to D. So when you have 2 odd vertices, the good thing about starting them at odd is that if you start on one odd, you will end on the other odd vertex. So start on C, go all the way around to the first triangle, across the bridge, around the other triangle, and finish on D. That is something that you can always do on an Euler path if you start from an odd. And it's recommended to start on that odd vertex, otherwise it's going to mess you up as you're trying to go around. And the last example I have for you guys is this one. Let's count the vertices. A has 1, 2, 3. B has 1, 2, 3. C has 1, 2, 3. And D has 1, 2, 3. All of them are odd. We have more than 2 odd vertices. We cannot do an order path and an order system on this one. So it will be either. And with that concludes our section. One note that I would like to point out, and this is a helpful hint, if we have a graph, let's say A has a little loop, the loop comes twice. So A will have 1, 2, 3, and 4. That's how you count loops. Loops count twice. Don't forget that, and remember to always count the vertices before you do an order path.